minerals and rocks. Let's get started. So, what is a mineral? Well, a mineral is an inorganic, naturally occurring solid that has a definite chemical composition and atomic structure. Now, that's quite a mouthful. Let's break that sentence down a little bit. For something to be classified as a mineral, it needs to be inorganic, meaning not living, ever was living, or composed of living matter or organic matter. It needs to be naturally occurring, meaning it can't be man-made. Additionally, it needs to be a solid under normal conditions on Earth's surface. It has to have a specific, definite chemical composition, a unique elemental makeup, and a specific atomic structure.
Minerals are the building blocks of rocks. All minerals have 5 common characteristics. They are solid, naturally occurring, inorganic, and each one has a specific chemical composition and crystalline structure. A crystal structure is the orderly geometric spatial arrangement of atoms in the structure of a mineral. Crystals are the main component of igneous and metamorphic rocks. A lattice is the arrangement of atoms in a crystal. It is orderly, meaning the arrangement repeats in a pattern, and it is three-dimensional. A crystal's color is determined by the elements it contains. Quartz can be transparent, milky white, pink, or purple when it has a lot of iron in it. The shape of the crystals depends on the way the elements group themselves together. Crystals grow in orderly geometric shapes. There are 7 main shapes of crystals: isometric, trigonal, hexagonal crystal, tetragonal crystal structure, orthorhombic crystal lattice, monoclinic, and triclinic. Scientists use X-rays to examine the crystal lattice and place the crystal into one of those groups. The chemical composition and crystal structure determine what mineral something is. For example, graphite and diamonds are both made of pure carbon, but they have different crystal structures that make them different minerals.
So let's talk about mineral color. Now, you might think mineral color is a good, simple characteristic to use for mineral identification. After all, minerals exist in all different colors. Why not use that as a jumping off point? But the fact is, there's a problem. There's a problem with using color to identify minerals, and let me explain what that problem is. Take a look at this necklace. The beads that make up this necklace are all made of quartz. That is to say, they are all the same mineral. So clearly, quartz exists in a variety of colors. And so I can't count on quartz being white or blue or green. It could be any of those colors. That poses a problem for mineral identification. Similarly, take a look at these minerals. I think you'd agree they're all purple in color. But the fact is, each of these is a different type of mineral. And so using color is not a reliable characteristic for identification.
Quartz. Quartz has a hardness of 7 and is the hardest mineral in this set. The luster is glassy, non-metallic, but be careful because quartz can be almost any color. It has conchoidal fracture, no cleavage, but is sometimes in crystal form. It has sharp edges and is a common rock-forming mineral. Calcite has a hardness of 3 and can be scratched with a knife. Its luster is vitreous to earthy and non-metallic. It has good cleavage and is rhombic. It can be many different colors and effervesces with a dilute 10% HCl.